Hi students, so in this video I'm going to show you how to solve a problem of an object kept on an inclined plane. Now this problem that I'm going to solve is on the 23rd page of your textbook, which is the revision book, which is here, Force, Friction and Torque, page number 23. Now I've written the problem down here and I'm going to read it. A 30-degree inclined plane is used to reduce the force required to raise a load of a 12 kilogram object where the coefficient of kinetic friction is 0.4. So that's the object. Calculate the component of weight acting down the plane, which is this force here. Calculate the component of normal reaction acting perpendicular to the plane, which is that force there. Calculate the kinetic frictional resistance and calculate the total force acting down the plane. Now, before you start a problem like this, you got to make a note of some information which is given. So I have here the mass of the object. So M stands for mass, which is 12 kilograms. Always make sure you write the units. Also, the coefficient of kinetic friction is 0.4. Kinetic friction is denoted by mu k and it is given as 0.4. Now this does not have any units, so make sure that you don't write any units. Calculate, let us start with part A, which is calculate the component of the weight acting down the plane. Now before I go into solving this, I'm going to revise with you resolution of forces. Now imagine you got a force F here and it is inclined at an angle theta with the vertical. In that case, the vertical component of the force Fv will be equal to F cos of theta and the horizontal component will be equal to F sin of theta. Now don't confuse this with a resolution of forces where a force is inclined with the horizontal. In that case, the vertical component is F sin theta and the horizontal component is F cos theta. But in this here, the force is inclined with the horizontal. That's that horizontal. Now, you can work with either of the systems, but for this question's sake, I'm going to work with force inclined with vertical. So, let us start the problem. So, calculate the component of the weight acting down the plane. Now, I'm going to act with resolution of forces wherein a force is inclined with vertical. So I have my force here mg, which is resolved in the vertical and the horizontal direction, which is inclined at an angle theta. I'm going to resolve this force mg here. Mass is 12 kilograms and g value is the acceleration due to gravity, which is equal to 9.81 meters per second squared, which is the unit of acceleration. So what I'm going to do is I'm going to place this post-it note exactly on my force mg and stick it there. You see, I can resolve that force mg, F equals to mg, that's the force, in vertical and horizontal. Now the horizontal component is F sin theta, goes along the plane, and the horizontal component goes along the plane and the vertical goes perpendicular to the plane. Now let's read the problem again, which says calculate the component of the weight acting down the plane, which is going down this way, which is F sin of theta. But I need to know this angle theta here. Now if you take a look at this post-it, you got this angle over here given to you as 30 degrees. So I'm going to get my scale and I'm going to complete my triangle. And if you take a look here, that's 30 degrees, and hence this will be 30 degrees. This piece of paper is overlaid exactly on my diagram, so that's 30 degrees. Now we need to find this angle here. Now how much will it be? Now I'll show you how to calculate this angle. Now because this is 30 degrees and this is going vertically downwards and this over here is 90, this angle over here will be 30 plus 90. Now angle A, B and C should be equal to 180. So this angle here will be 180 minus 30 minus 90. So that angle will be 60 degrees. Now because that is 60, this angle, now this is the perpendicular, horizontal is perpendicular to the vertical. If that is 60, this will be equal to 90 minus this 60 here, which is equal to 30. So my theta here will be equal to 30 degrees. Now that I have my theta value, I can solve this problem. Now you see, in this problem, theta value at which the plane is inclined with is the same as this angle here. That's it's trigonometry and a geometry of a triangle. So this angle will always be 30. This angle and this angle is in fact will always be the same. Now let me calculate the component of the weight acting down the plane. So that's going downwards, which is equal to F sine of theta. Now my given data here, I'm going to write the A and I'm going to name the component as F, and that is going to be equal to F sine of theta. Now my force F is equal to mass times gravity. So I can write this as mg sine theta. And my mass m is given as, I'm going to write it here again, mu is 0.4, m equals to 12 kg, and my g value is 9.81 meters per second squared. So m value is 12, g value is 9.81, sine of theta is 30 degrees, which is this angle 30 here, equal to sine, and this I can enter in my calculator. 12 times 9.81 times sine of 30, close bracket, 58.86. That's 58.86 Newton. The units of force is Newton. Now let us calculate the B part. Calculate the component of normal reaction acting perpendicular to the plane, which is this here. And if you take a look at my diagram, it is simply FV because it is perpendicular to the plane. That's my plane here, and this is the force that I need to find. So I'm going to name this, say, FH. So that's A. My B part is FV, which will be equal to F cos of theta. F cos theta. F is equal to mg cos theta. M is 12. G is 9.81. And theta is 30. And hence that will be equal to 12 times 9.81 times cos of 30 close bracket 101.94 101.94 Newton. So now I have calculated my B part. Now let's take a look at C part, which is calculate the kinetic frictional resistance. C part. Kinetic frictional resistance is, now when you learnt about frictional force, we have a formula, F normal equals to mu times Fk equals to mu times normal force. Normal force is basically the force normal to the plane. So this is my object here, and normal force is the force going perpendicular. And if you take a look at the figure, the force going perpendicular is my Fv. So F kinetic is what we need to find. F kinetic or kinetic force, kinetic frictional resistance is basically the resistance that this object will experience as it goes upwards, because it is scraping against this plane. And that is going to, when I push my object with a force F, it's going to scrape along this plane, and that is my frictional force, which is what we go to find here, which is the kinetic frictional resistance. And that is going to be equal to mu, which is 0.4, times n. Now my n is equal to Fv, which is my perpendicular force, which is normal reaction acting perpendicular. Acting perpendicular. This is the perpendicular sign. So n equals to Fv, and we have Fv equals to 101.94 Newton. And I'm going to substitute that value here. And hence my kinetic frictional resistance Fk will be equal to 0.4 times 101.94. That's going to be equal to 40.776 Newton. So this here is my C part. And my D part says calculate the total force acting down the plane. Total force acting down the plane. So what is my total force acting down the plane? If you take a look at the diagram here, you got the force going in the downward direction, which is component of the weight acting down the plane, which we calculated as equals to FH plus the frictional force which is generated when you move this object upwards. So there's a frictional force and the force going downwards, and that is going to be equal to Fk, and hence total force will be equal to Fh, which we calculated as 58.86 plus Fk, which is 40.77. And that is going to be equal to 58.86 plus 40.77, 99.63 units Newton. So I have now solved this problem, and I have calculated the A part, B part, C part and D part. A being FH equals to 58.86, B being FV equals to 101.94, C being Fk equals to 40.77 Newton, and F total force going downwards is equal to 99.63. It is a very good practice to highlight your answer so that when your question paper is being marked, the examiner can find the answers with ease. So it's a very good practice. Okay, so that's the solution for A, B, C and D. Now you try it. Good luck.